that we are going to discuss is a comparator circuit. Now, before we discuss this circuit at length, let us take an example of an industry where we make use of these circuits called comparators. So in an industrial situation or in industrial applications where we have automatic, we want to have an automatic control system or ACS. In automatic control system, we don't require any human intervention. Therefore, all the parameters are preset and our system responds in such a manner that in the event of fluctuation of any of the parameters, the system does the corrective measures. That means all the corrections are done by the system itself. You can imagine that we have a steel plant where we are producing steel, and then we want this process to remain automatic because the temperatures may be very high for humans to control the parameters. Therefore, what we can do, we can set one of the terminals of the op amp at a reference. You can imagine like this. We can set one of the terminals of the op amp at a voltage called reference voltage, and the other input can be from the real time situation. That means you can imagine that when we are operating the plant, the steel plant, we have a particular temperature for getting better quality of steel. Suppose that temperature is 500 degrees centigrade, and we convert this through a calibration equation. We convert this temperature into equivalent voltage. Suppose this voltage is 5 volts. So we apply it here. So that 5 volts is taken as the reference voltage, and then we have a temperature sensor which converts the actual temperature of the plant into voltage. So that voltage source can be assumed as this input voltage which is changing. So we know the principle of operation of a op amp. Here if the voltage is V2 and the voltage here is V1, then V1 minus V2 is the output, and output will be equal to A times V1 minus V2. This is the principle of operation of a difference amplifier, right? So that means if the voltage of any of the terminals changes, it will reflect upon the output. How will it reflect upon the output? Any answers? If the voltage of any of the terminal, because one of the terminals is constant now, if the voltage of this terminal changes, what will happen to the output? So in the event of change of voltage of this terminal, it will reflect upon the output in terms of the saturation levels. The output will be either positive saturation or it will go into the negative saturation, and like that. So that means we can change the state of the device. If the device goes into positive saturation, for example, I'm taking an example here. For example, if the device goes into positive saturation, we can switch on the heater, or we can switch on the furnace which is burning the steel, right? It is creating the iron ore, right? And suppose it is going negative, we can switch off the heater or the furnace, and that means the action of this element here, the element that we are using is IC741. It performs a crucial role here by controlling the process. That means if the temperature is more than 500 degrees centigrade, in that case the furnace will be switched off till the time the temperature again approaches to 500 degrees centigrade. Once it is lesser than 500 degrees centigrade and it falls below 500 degrees centigrade, again the heater will be switched on, right? So that is how a comparator circuit works. Now I'm going to tell you in terms of circuit how the comparator circuit is going to work, the basic principle of comparator, and before that I'll tell you the basics of op amp that we have discussed already, but I would like to emphasize them again for you. So we have a comparator circuit, and in comparator we have to study two types of comparator circuits.